Hello student, previous class we discussed about the atomic mass. What is atomic mass? Here I can say that atomic mass is equal to the mass of an atom of an element divided by 1 by 12 into mass of C12 atom. This is the formula for the calculation of the atomic mass. I have given some examples of atomic mass. Here the atomic mass of oxygen is 16 mu. By using this formula, uh, you can calculate the atomic mass of oxygen atom. Here I have also given the second example, that is atomic mass of nitrogen. There are some examples I have given to explain the term atomic mass. Here a table is given. In this table, I have listed some elements and their atomic mass. It is highly necessary to remember this table. Otherwise, it is difficult to calculate the molecular mass of a molecule. So, kindly remember this table. Next, I have discussed already about the methods for the determination of atomic mass. Here I have used the first method. Atomic mass is equal to equivalent mass into valency. Here I have also done some examples for the calculation of atomic mass by using this method. Next, I have also used the Vapour density method. Here we can calculate the atomic mass by using this formula. Atomic mass is equal to 2 into Vapour density divided by atomicity. Here we clearly explain the term atomic city and also vapor density. Next, I have also done some problems related to this formula. Next, another method is the Dulong-Pettis method. This is a very important method. As per the Dulong-Pettis method, approximate atomic mass is equal to 6.4 divided by specific heat. By using this formula, I have also done few problems. Here is the problem is given. Next, in this class, I will discuss about the molecular mass. Here, we can clearly explain about the molecular mass. What is a molecular mass? The molecular mass of a molecule is the number of times of a molecule of that substance is heavier than 1 by 12th of the mass of an atom of C12 isotope. Like the atomic mass, you also clearly explain about the molecular mass by using the same concept for the atomic mass. Only difference is the in atomic mass you clearly related about the atom, but here in molecular mass you will related about the molecules. By using the atomic mass, you can calculate the molecular mass. Molecular mass of methane. Here I have taken a molecule that is methane. The molecular mass of methane is your 16 AMU. Like the atomic mass, you can also compare the molecular mass with the C12 atom. Here, methane molecule having 16 AMU means you can say that a molecule of methane is 16 times heavier than 1 by 12th of the mass of C12 atom. Mass of water molecule. Here I have given mass of water molecule, that is your 18 m. That means you can say that molecule of a water molecule is 16 times heavier than 1 by 12th of the mass of C12 atom. Similarly, you can think about the CH4 molecule. Here, the molecular mass is your 16 AMU. That means you can say that molecule of methane molecule is 16 times heavier than 1 by 12th the mass of a C12 atom. When a molecular mass is expressed in gram, when a molecular mass is expressed in gram, that is called gram molecular mass. Remember, this is simply called as GMM. Shortly, it is represented GMM, gram molecular mass. Or you can say that gram molecule. Look at that. Molecular mass of methane is your 16 AMU. But when I will convert the molecular mass into gram molecular mass, that means here I can say that gram molecular mass of methane is your 16 gram. You can say that gram molecular mass of methane is your 16 gram. Similarly, you can say that suppose take water molecule. You know that water molecule having the molecular mass is your 18 AMU. But if you will convert the molecular mass of water into gram molecular mass of water, then here you can write 18 gram. Simply remove the AMU atomic mass unit and write GM. That means here we can convert the molecular mass into gram molecular mass by replacing the AMU and use the GM. You can take another example also. Suppose I will take another molecule, that is your simply I can take carbon dioxide. Here molecular mass of carbon dioxide equal to 1 into 12 plus 2 into that is your 16. That means your 12 plus 32, that is your 44. That means you can say that 44 AMU is the molecular mass of carbon dioxide. But if you want to explain about the gram molecular mass of carbon dioxide, that is your GMM of carbon dioxide, then you can write 44 gram. This is the gram molecular mass of carbon dioxide. There are different methods for the determination of molecular mass. At first, I will explain about the general method. In general method, the molecular mass of a molecule of the substance is the algebraic sum of the atomic mass of the different atoms present in one molecule of the substance. That means in this method, just you add the atomic mass of the atom present in the molecules. Look at that. Take an example. Our aim to find out the molecular mass of sodium carbonate. The formula of sodium carbonate is Na2CO3. Here, the sodium atom, the number of sodium atom is your 2. There are 2 sodium atom is present. One carbon atom is present. 3 oxygen atom is present. Sodium atom having the atomic mass is your 23. Carbon atom having the atomic mass is your 12. Oxygen atom having the atomic mass is your, that is your 16. Look at that. How can I calculate the molecular mass of sodium carbonate? Here I can write 2 into atomic mass of sodium. Why I have written here 2 into atomic mass of sodium? Because here 2 sodium atom is present. Then add and then take the algebraic sum. That means here you can give the plus sign. 1 into atomic mass of carbon, because here one carbon atom is present. Like that you can here also like give plus sign and then write 3 into atomic mass of oxygen, because here 3 oxygen atom is present. Now put the atomic mass of every atoms Atomic mass of sodium is your 23, so I have written here 2 into 23. Atomic mass of carbon is your 12, so I have written 1 into 12. Next, atomic mass of oxygen is your 16, so I have written here 3 into 16. Next, I will add. After addition, it is seen that that sum total is your, that is your 106, 106. That means here you can say that molecular mass of sodium carbonate is your 106, 106 AMU. So next, suppose take another example. Suppose you aim to find out the molecular mass of glucose. Suppose find out the molecular mass of glucose. Uh, our aim to find out the molecular mass of glucose. You know that the molecular formula of glucose is your what? C6, 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 H12O6. Here, number of carbon atom is your 6. Number of hydrogen atom present in the glucose molecule is your 12. Number of oxygen atom present in the glucose molecule is your 6. We know that atomic mass of carbon is your how much? 12. Atomic mass of hydrogen is your 1. Atomic mass of oxygen is your 16. Now, apply the formula. As per the formula, here I can write molecular mass equal to 6 into atomic mass of carbon plus 12 into atomic atomic mass of hydrogen plus 6 into atomic mass of oxygen. Now put the atomic mass of every atom. Then here I can write 6 into atomic mass of carbon means that is your 6. Sorry, atomic mass of carbon is your 12. So here I can write 6 into 12 plus 12 into atomic mass of hydrogen. Atomic mass of hydrogen is your 1. So here I can write 12 into 1. Next, here I will give the plus sign. 6 into atomic mass of oxygen. Atomic mass of oxygen is your 16. So here I can write 6 into 16. Here I can write 6 into 12, that is your 72. Next is that is your 12. Next 6 into 16, that is your 96. After addition, it is seen that 6 plus 2, that is your 10. Remain is 1. 1 plus 9, that is your 10. 11, and that is your 7. 11 plus 7, that is your 18. So here I can say that molecular mass of glucose is your 180 mu. If I will convert into gram molecular mass, here I can write 180 gram. Molecular mass of carbon dioxide, molecular mass of carbon monoxide. You can take another example for the calculation of molecular mass by using this simple method. Just algebraic sum of the atomic mass present in the algebraic sum of the atomic mass of the atoms present in the molecules. Next, take another example, that is your vapor density method. Molecular mass is equal to 2 into vapor density. Remember, in atomic mass, we also discussed about this vapor density method. You look at that here. The formula is what? Atomic mass is equal to 2 into vapor density divided by atomic city. But in molecular mass, you can say that molecular mass is equal to 2 into vapor density. Here, an important point is given. What is STP and NTP? STP means standard temperature and pressure. NTP means normal temperature and pressure. In STP condition, the temperature is your 0 degree centigrade. In Kelvin, it is considered as 273 Kelvin. And for STP, the pressure is 1 atm. You can say that 760 mmHg. In NTP, the temperature is your 20 degree centigrade or 293 Kelvin, and pressure is 1 atm or 760 mmHg. In both STP and NTP condition, the pressure is 1 atm and 1 atm. But in case of temperature, we can find different thing. In STP, the temperature is 0 degree centigrade. Or in mole concept, I will clearly explain about the relationship between volume and volume and mole concept. Vol- in NTP condition, the volume is slightly different. That is, in NTP condition, the volume is 22 liter. Take an problem. By using this formula, I will explain about a problem. A gas occupy 250 ml at a STP, and its mass is 0.44 mm 0.445 gram. Calculate the molecular mass of the gas using vapor density method. For every problem, you have the first step is your write the data given you. So here I can write what are the given data. At first, look at that. Here a gas occupy 250 ml at STP. That means volume of gas. Here I can say that volume of gas is your 250 ml. So here I have written volume of gas is equal to 250 ml. Again, read the question. A gas occupied 250 ml at STP and its mass is 0.44 gram. That means here you can write weight of 250 ml of gas in ml. The volume is taken in ml. At STP condition is your, that is your 0.445 gram. You know that molecular mass is equal to 2 into 2 into vapor density. And again, you know that vapor density is equal to molecular mass. Here we can apply the formula. What is the formula for vapor density? This is the formula for vapor density. Vapor density is equal to mass of xml of a gas at a STP divided by mass of xml of hydrogen gas at a STP. Here you know that weight of 1 ml of hydrogen gas 0.89. There are 4 zero after point. That means weight of 1 ml of hydrogen at STP is your, we can say that 0.000089. Suppose I want to find out the vapor density of 5 ml of carbon dioxide. The weight of 5 ml of carbon dioxide is, how can you calculate the vapor density of carbon dioxide? By using formula, you can calculate the vapor density of carbon dioxide. Remember an important point for vapor density, the gas, the mass is compared with the mass of hydrogen gas. Remember both gas having the same volume. So here I have taken XML. That means vapor density is equal to mass of xml of a gas. Suppose here I have taken carbon dioxide. That means here I can write mass of xml of carbon dioxide at STP. Here volume, this xml is the volume of carbon dioxide. So here I can say that mass of 5 at STP divided by mass of same volume. That means 5 ml of hydrogen gas at STP. Suppose if I will take here 10 ml instead of 5 ml, I have taken 10 ml. So here I can change the formula for the calculation of 10 ml of carbon dioxide. For the calculation of vapor density of 10 ml of carbon dioxide, you can write the formula mass of 10 ml of carbon dioxide at STP divided by mass of 10 ml of hydrogen gas at STP. Suppose you take 50 ml of carbon dioxide, then here you can change the formula like that mass of 50 ml of carbon dioxide at STP divided by mass of 50 ml of hydrogen gas at STP. Next, putting the value of weight of hydrogen gas and weight of the carbon dioxide, you can able to find out the vapor density. Here I have taken our first question is what is the vapor density of 5 ml of carbon dioxide whose weight is 10 gram. Here I have suppose I have taken, then what will be the formula? Vapor density is equal to mass of dioxide 5 ml 5 ml of hydrogen. It is the formula to calculate the vapor density of 5 ml of carbon dioxide. Now put here we know that 5 ml of carbon dioxide weight is 10 gram. So here you can for way to calculate the vapor density of 5 ml of carbon dioxide. Now look at that. Here I can write molecular mass is equal to 2 into mass of xml of a gas at STP divided by mass of xml of hydrogen gas at STP. After simplification, here you can write suppose take the mass of xml of gas W. So here write in like that x into 0.0089 gram. Here again read the question. A gas occupied 250 ml at ST 5 gram. That means the weight of 250 ml gas is your how much? 0.2 into 0.445 gram divided by 250.0089 gram. Here I have taken 250. Why? Because the same volume is here given. It is necessary to take same volume. The volume of gas is your 250 ml, so it is necessary to take 250 ml of hydrogen. Suppose here point. Suppose here 500 ml is given. Here you have taken also 500. After calculation, it is seen that the molecular mass of the gas is your that is your 40 AMU. So here you can write the molecular mass of the gas is your 40 AMU. This is the problem number 1. Take another problem. Take a simple problem. Suppose the vapor density is given directly. Here look at that. In this problem, in problem number 1, the vapor density is not given. The data is given for the calculation of vapor density. So after calculation of the vapor density of the molecular mass is equal to 2 into vapor density. Look at that. Already vapor density is given. In this problem, the vapor density of the gas is found to be 22. Your vapor density is that given. Only simply put the write the formula and put the data and get the answer. of gas is your found to be 22. Calculate the molecular mass of the gas. Your aim to calculate the molecular mass of gas. Here I can write what are the given data. Vapor density is your 22. We know that molecular mass is equal to 2 into vapor density. Now put the vapor density here. Here put the vapor density, that is your 22. So here I can write 2 into 22 is equal to 44. So here I can say conclude the molecular mass of the gas is 44 AMU. Suppose here a question will ask calculate the gram molecular mass. Suppose a question will ask what is the gram molecular mass of the gas. So next what we will do? Simply you can take another sentence. Therefore, here you can write therefore gram molecular mass of the gas is your how much of the gas is your 44 gram, because the molecular mass is your 44 AMU. Just change the AMU into GM. You can find the gram molecular mass of the gas. Your answer is your 44 AMU for molecular mass. This is the method. Look at that. By using this formula, molecular mass is equal to 2 into vapor density. You can solve such type of problem. Next, move to the diffusion method.